Hello everybody and welcome to your video notes on Learning Target 8.4 at the meets level. You should have watched the approaching and basic level videos before watching this one. And yeah, let's go ahead and get started. So this learning target is focused on, I've got two things right here. So one is the learning target and the other is the essential question. So learning target 8.4 at the meets level says, I can make qualitative predictions using Ohm's law. Now, let's revisit this qualitative word. So what does that mean? Generally, that means no numbers. Or using your words. Now, if you think back to the last time we used the word qualitative, that's when we did LOL diagrams, where we did like the energy bar charts. We had energy going in or out of the system, and so that was qualitative. Now, we're also going to be doing some qualitative stuff here, except we're not going to be using energy bar charts. We're going to be using words to describe something that's happening in the circuit. And I'll do some examples so you know what I'm talking about, but just so you know, that's where we're going with this. And this essential question might be something that you're already thinking about or something that might come up along the way, which is, how can I make predictions using Ohm's law without plugging numbers into the equation? Because we know that Ohm's law is I equals V over R. Sometimes it's written as V equals I times R2, but we're generally going to stick to this way. So you might be thinking, that's an equation, Mr. Basil. How can I do something qualitative that doesn't use numbers with Ohm's law? Well, that's what the point of this video is. So here we go. So here is a question for you. So I'll just go ahead and start by reading the question. A simple circuit has a battery, light bulb, and switch. If the battery is switched out for a battery with 10 times more voltage, what will happen to the current in the circuit? The original current was 5 amps. What will the new current be? Explain your answer using Ohm's law. So it might help to draw out the circuit first. So I've got my battery. Got a switch here. And a light bulb. And that's what we got. So we're going to switch this out. So let's say that this is, I don't know, some voltage. And then we're going to get a new one. Looks identical. This one is going to be 10 times the voltage. Okay, so in order to do this, we have to really think about, well, what does Ohm's law really tell us? Because really, that's what we're going to use to solve our answer. Remember, so if you think back to the notes that we've talked about in the past, and the simulations that you've done up until now, what we know is that resistance and current are inversely related. And voltage and current are directly related. Now, inversely could be, I'll sometimes say indirectly, because inversely and indirectly related are more, are the same thing. And sometimes indirectly is used when we're talking about direct relationships because they're more like, they're opposites really. Inversely and directly are also opposite. The reason why I'm using inversely is you've probably heard that in math class before, but either way. So then what that actually means is that, so if something is inversely related, that means if resistance goes up, then the current is going to go down. Or if resistance goes down, current goes up. Okay, so basically they do the opposite. And then for the direct one, you probably have already guessed it. So if they're directly related, that means that they do the same thing. So if voltage goes up, then current also goes up. Or if voltage goes down, then current also goes down. And the disclaimer that, so then the nice thing about this equation is that there's not like a 1/2 in there, or like a squared, or anything like that. The variables are just as they are. So that means that whatever the one does, the other does the same or opposite by that amount. So what do I mean by that? So like if the resistance goes up, the current goes down. So if the resistance goes up by 2 times, then the current goes down by 2 times. Or you can think about it like it's being cut in half. If the voltage goes up by 2 times, then the current goes up by 2 times. If the voltage goes down by 2 times, or you can think about it like by getting cut in half, then the current also goes down by 2 times, or you can think about it like it's being cut in half. Okay? So, let's come back over here and see how it applies to this problem. So if the battery is switched out for another one that's 10 times more voltage, what will happen to the current? Well, according to this equation, I equals V over R, these two are directly related. So the voltage goes up by 10, that means that the current will also go up by 10. So if the original current was 5 amps, the new current will be 50 amps. Okay, so those are our answers, and then we have to explain using Ohm's law. So that would look something like this. Okay, so this is what you'd be looking for in order to get full credit for this. So the current will increase by 10 times, the new current will be 50 amps, and the voltage and current are directly related, so if the voltage increases, then the current will increase by the same amount. Okay, that's the preferred way of doing it, but if the numbers really work for you, then you can also just make up some numbers and then explain the answer using Ohm's law in that way. So like if you had the first case, let's say you just make up a voltage of 1 volt, and then you could say the same. You can say the same thing at the beginning, and then your explanation, instead of using words, you could do something like this. I know this is true because, and then have V equals 1 volt. Then I equals V over R. You could say we'd have to make up a resistance too, because that's not given to us. So we'd say 1 volt divided by 10 ohms, that equals 0.1 amps. And then we could say, then we could have V equals 10 volts and R equals 10 ohms. You could say that I equals 10 volts divided by 10 ohms. We'd end up with 1 amp, which is 10 times bigger. Okay, so I just kind of made that up. I just went in and said, okay, 1 volt, 10 ohms. I just made that up. So together that gives us 0.1 amps, which isn't the same as what it says in the problem, but just as an example, I did that. And I said, okay, so if I keep the resistance the same and then increase the voltage by 10 times, I can plug those numbers in and see that 1 amp is 10 times bigger than 0.1 amps. So if this way makes sense for you, go for it, but I'm going to say that this way is the way that most people are going to do it, because that makes the most sense to people. Alright, I'm going to do one more example. Alright, so now we have this other problem here. You can ignore this little points thing here. We've got a circuit that has 4 identical light bulbs and a battery. With the switch closed, so I didn't even have the switch on there, you remove 2 of the light bulbs and replace them with wires. What happens to the current through the circuit? So, each of these resistors you can think of, or you can think of each of these light bulbs as being a resistor that has some sort of resistance R. And we can say that R equals like 1 ohm if that helps you visualize it. But since they're all just in a straight row like this, it has a total resistance of maybe like 4 ohms, or just whatever. If we take 2 of the light bulbs out, we get a new circuit that looks like this. And now we just have 2 R's, or a total resistance of 2 ohms. If each of these is 1 ohm. Okay? So really what we're doing is we're cutting the resistance in half. You can think of that as decreasing. You can think of decreasing by a factor of 2 times, or changing by factor of 1/2. Okay, so either of those 3 things, that's really what we're doing here. We're cutting the resistance in half, decreasing by a factor of 2 times, or changing by a factor of 1/2. Okay? So then, does that mean that, so then the question is, what happens to the current? So does the current decrease by 1/2? Does it remain the same? Or does it double? Okay? So use Ohm's law to explain your answer. So if we go back over here, we're talking about how resistance and current are related. So if one goes up, the other goes down. If one goes down, the other goes up. So over here, the resistance is going from, let me just get this back on screen. So resistance is going down by 2 times. Okay, so if resistance is going down, that means that the current will increase by 2 times. Okay, so we would say that it doubles. And then we have to use Ohm's law to explain our answer. So I'm going to use my words to describe this. If you want to use numbers, you can see my previous example on how to do it with numbers, but I'm going to say that you're probably just going to want to use your words to describe this. So, the current will So my answer would be that the current doubles, and the current will increase by 2 times because resistance and current are inversely related. This means that when resistance decreases, current increases by the same factor. So you need this in order to get full points for a problem like this. Alright, that's all. Thanks for listening.